All right, so this is just a continuation of the last video. I'm going to basically be proving the median, the fact that if you had the number line, then the optimal place would just to pick the median of B1, B2, and B3. So if it B1, B2, B3, etc., you pick the median such that X is the median, right? Okay, so if X is the median of a set, then there are always the same numbers. It splits the data such that there's the same numbers to the left and the same number for the right. Like even if it's like an even amount of numbers, right? Like let's say 1, 2, 3, 4, the median is 2 plus 3 over 2, which is 2.5. Then 2.5 still splits the data into two equal sets, right? And then if it's odd, then it's not. It's the same thing, except that you don't have to average stuff out. So that's where the location of X is, right? The location of X will split. Uh, so let's say you have we had J values in the video. So if you had J values, we'll have like we're gonna have J over 2 in each one. So let's say we have B1 all the way to BJ over 2, J over 2. Like, so if it say like those values, etc. And then we'll have J over 2 plus 1, BJ over 2 plus 2, all the way to BJ, right? So we have this, right? So then in order to prove this, I'm going to use a proof by contradiction technique. I'm going to use two cases. I'm going to say, well, to prove that it's contradiction, to use proof by contradiction, let's assume two cases. Let's first assume that it's optimal to make x to it's optimal to move x to the left, which means that the optimal spot is to the left. And let's say the optimal spot to the left is x minus some distance d, right? Let's say that this is the optimal spot, that x actually should be in this location. So so the optimal spot is actually x minus d. Let's say that x minus d so there's initially j values here. Let's say that let's say that x minus d creates, let me write it down. Let's say that, wait, make sure I'm recording this. Okay. Yeah, okay. Let's say that x minus d makes uh k more values on the right of the optimal spot. And if it makes k more values on the right of the most optimal spot, that also means it makes k less values on the left of the optimal spot. So in here, there was j values to the right, and there's j to the left. If you move x minus d, then that might cause there to be like more. That might cause there to be like more values on the right, and then less values on the left. And let's just say that there's k. So now on our left, we have j minus k. On the right, we have j plus k. And let's say that the sum for when x was in the median, let's say that was s, right? So let's say that's s. Well, then if we put it, let's say that was s. Let's say we had like some sum function. So like f of x equals x, right? Then we note that f of x minus d, we note that for all the values um, on the right, we know that their distance increased. So we can take s, and we know that their distance. Hold on, give me a second. Then we know that for s minus d, each one of these, the s, we know that since there's k new values, so uh, it increased j plus k. Um, they increased by distance of d. So we can add this. So s plus j plus k plus d. And then we note that we also have to subtract that the fact that there's j minus k values that also uh, there's j minus k values that also decreased. So I'll subtract this from the fact that they're obviously decreased from d, right? So then basically all we have to do is prove that f of x minus d is more. So if we prove that, we have to prove that f of x minus d is more than f, or is basically, actually I should say this, is greater than or equal to the optimal solution, which is x, right? And this is obvious because obviously this thing, so this thing that I circled, this thing that I kind of bracketed in red, this thing is going to be positive. We're only going to be adding it because we know that j minus k. Um, so wait, hold on, j minus k. Um, like, okay, let's just expand this out so I can just get some consistency. Let me get some consistency here. So if we expand this out, we get dj plus dk, right? And then minus uh the quantity minus dj, and then plus uh plus dk. So we get s plus 2dk. Well, because d is a distance, we're good. And we note that d and k are both greater than 0 because d is a distance and k is an integer. Obviously you can't have like negative 5 more values or negative. Therefore we've just proven it because it's s plus 2dk. Thus our answer, and d and k are both greater than 0, thus f of x minus d is greater than or equal to f of x. Therefore that case is wrong. And we can also do the same thing for if we said the optimal spot was x plus d. It would literally just be the same thing. We would just have, if we just did the same design, we would have like f of x plus d would equal the fact that, let's say this created, it would just be this, like s plus j minus k times d minus, so j would be j minus k minus d minus j plus k times d, um and that would be dj plus dk. We have minus dj, and then we have minus dk. um I'm sure I did something wrong, but anyways, actually, you know what, I think I messed up the equation here. I'm too lazy to fix that up, and I also have to sleep soon. But anyways, if you prove that it's not you, anyways, since it's symmetric, right? Since the distances are symmetric, you could also do the same thing with the x plus d case. Use the same idea for the x plus d case, and you've proven it, right? So I'm not going to do it for the right case, but you can all, the next step would just be assume that it's optimal to move x to the right, and uh, that would you would get the same result. You would get something like s plus 2dk. Maybe it's s plus 2jk. Maybe I think it's gonna be like s plus 2jk. I don't know. I didn't memorize this. I kind of just proved this on spot. I had an idea to prove it, and I just proved it on spot. But yeah, that's basically the proof of this. It's symmetric, so we can also assume that if it's not optimal to move it to the left, then it's obviously not going to be optimal to move it to the right, since this is like a generalization. And I'll leave it as an exercise for you to do the right case, since I kind of messed it up here, and I don't want to do it, and I also have to sleep, and I want to keep this video brief. So, bye bye.